Hello, in this lecture we'll answer two questions. On both questions we'll find out the area of a trapezoid. So what is a trapezoid? A trapezoid is a quadrilateral with one pair of parallel sides. This is quadrilateral ABCD, and here we have side AB. In quadrilateral ABCD, side AB is parallel to the opposite side DC, and therefore this quadrilateral is defined as a trapezoid. So if we define the length of side AB as B and the length of side DC as A, then the area of this trapezoid is equal to the sum of its two parallel sides, that is to say A plus B, times the height edge over 2. The height edge must reach 90 degrees with the two parallel bases. So repeat again, a trapezoid is a quadrilateral with one pair of parallel sides, and the area of a trapezoid is equal to the sum of its two parallel bases times the height over 2. In this case it is A plus B times edge over 2. So we start with the first question. In the drawing we have trapezoid ABCD. You know that the perimeter of this trapezoid ABCD is equal to 16. So what is the perimeter of a trapezoid? The perimeter of a trapezoid is the sum. The perimeter of a trapezoid is the sum of the lengths of all the sides of the trapezoid. In this trapezoid ABCD, it means that the perimeter is actually AB plus AD plus DC plus CB. And you know that it is equal to 16. We also know that side AB equals to 2 units in its length. So in the next step we define the length of side AD as A. We define the length of side DC as B. And it is given as the question that side DC equals to side BC. So if DC is B, then if DC is B, then BC must be also equal to B because they are equal to each other. So according to what is given in the question, the perimeter of this trapezoid is equal to 16 units. That is to say AB plus AD plus DC plus CB equals to 16. So I write it down. AB plus AD plus DC plus CB equals to 16. AB plus AD plus DC plus CB equals to 16. AB equals to 2 units in its length according to what is given as the question. AB equals to 2. AD equals to A units in its length according to our definition. Likewise, DC equals to B, and BC also equals to B. So in total, we have found out that two plus A plus B equals to 16. Here we subtract 2 from this equation, and we get that A plus B is A plus 2B, and it is equals to 14 minus 2 is 16 minus 2 is 14. So A plus B equals to 14. Here we subtract 2B from this equation, and we get that A equals to 14 minus 2B. Side AD equals to A units in its length, and A equals to 14 minus 2B units in its length. In the next step, we will do a construction, that is to say, from this vertex B of this trapezoid ABCD, we will draw perpendicular on DC. So actually, this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point B in DC. This point is point M. By doing this construction, we're going to do quadrangle AB, MD. Inside quadrangle AB, MD, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees. So 270 degrees plus the size of this 4 facing angle. In total, it must be equal to 360 degrees. According to the rule that says that the sum of the angles in any quadrangle is equal to 360 degrees. Therefore, this 4 facing angle must be equal to 90 degrees in its size. So inside quadrangle ABMD we have 4 right angles, and according to rule 5, any quadrangle that has 4 right angles must be this left angle if not a square. So we relate to this quadrangle ABMD as a left angle because it has 4 right angles. So I write it down. This is quadrangle ABMD, and it is a left angle according to rule 5. But we also know that the opposite sides of a left angle are equal to each other. So in left angle ABMD, side AB must be equal to the opposite side DM. But AB is 2 according to what is given as the equation, therefore the opposite side DM must be also equal to 2 units in its length. Likewise, according to the same rule, in the same left angle ABMD, side AD must be equal to the opposite side VM, but AD is 14 minus 2B, therefore the opposite side VM must be also equal to 14 minus 2B units in its length. What is the length of this between line 7 MC? MC equals to DC minus DM. So I write it down. MC equals to DC minus DM. So MC equals to DC. DC equals to B units according to what according to our definition. So this is B and DM is 2 according to what we already found out. So in total, MC equals to B minus 2 units in its length. In the next step, I will copy this right angle BMC in a new page, and we will implement the Pythagoras theorem on this right angle BMC. According to the Pythagoras theorem, in any right angle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. Here by PT is a relation for Pythagoras theorem. So actually, this is the right angle BMC that I come from the original drawing. According to the Pythagoras theorem, in this right angle BMC, BC squared, that is the square of the hypotenuse, is equal to bm square plus mc square. So write it down. bc square, that is the square of the hypotenuse, must be equal to bm square plus mc square. The hypotenuse BC is B, therefore BC square is B square, and it is equals to BM square. BM is 14 minus 2B, therefore BM square is 14 minus 2B square. Plus MC square. MC is B minus 2, therefore MC square is B minus 2 square. So in total, if you found out that B square equals to 14 minus 2B square plus B minus 2 square. So here we open the brackets on this side of this equation, and we get that B square equals to 14 minus 2B square. 14 minus 2B square equals to 14 squared, that is 196, plus 2B squared. 2B squared is 4B squared. Minus 2 times 14 is minus 28, and minus 28 times 2b is minus 56b. And we have also plus b minus 2 square. b minus 2 square equals to b square plus 2 square b square plus 2 square, that is 4, minus 2 times b times 2, that is minus 4b. So here we have b square on both sides of this equation, so b square gets cancelled. After we cancel b square, on this side of the equation we left with nothing, that is to say 0. And on the other side of this equation we have 196 plus 4, that is 200. We have also minus 56b minus 4b is minus 60b. And we have also plus 4b square. So in total, if you found out that 0 equals to 200 minus 16 minus 60b plus 4b square. Here we divide this equation by 4, and finally get that 4b square over 4 is b square, and we have minus 60b over 4 is minus 15b. And 200 over 4 is 50, and it is equals to 0 over 4 is 0. So in total, if you found out that b squared minus 15b plus 50 equals to 0. So this is the quadratic equation, and the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. In this general formula, capital A, capital B, and capital C are the coefficients of this quadratic equation, and x is the variable that we are looking for. And we find out the value of x according to the following formula. X equals to minus b plus minus square root of b squared plus 4 times a times c over 2a. Now specific quadratic equation, that is to say b squared plus 15b plus 50 equals to 0. The variable that we are looking for is small b. So x equals to small b. Again, small b is the variable that we are looking for in our specific quadratic equation, this specific quadratic equation. The coefficient a equals to 1, the coefficient b equals to minus 15 and the coefficient c equals to 50. So the only thing that is left to do is to put this data of our specific quadratic equation inside this general formula for x, and in this way we find out the value of the values of small b, because we are looking for small b. That is the variable that we are looking for. So we'll do it now, and we have here x, so x is small b, therefore we solve x by small b, and it is equals to minus b. It is capital B, so b equals to minus 15, therefore minus b is minus 15, that is plus 15, plus minus square root of b squared. B is minus 15, therefore b squared is minus 15 squared, that is 225, minus 4 times a is also minus 4 times 1 is minus 4 times c. C is 50, so minus 4 times 50 is minus 200, divided by 2a. A is 1, so 2a is 2 times 1, that is 2. So in total, we actually found out that b equals to 15 plus minus square root of 225 minus 200 over 2. So b equals to 15 plus minus, inside the root we have 225 minus 200. 225 minus 200 is 25, so inside the root we left only with 25 divided by 2. So b equals to 15 plus minus, and the square root of 25 is 5 over 2. So here we have two solutions that are possible for b. We define the first solution for b as b1 and the second solution as b2. So the first solution for b is b1 and b1 equals to 15 plus 5 over 2. 15 plus 5 is 20, and 20 over 2 is 10. So the first solution for b is b1, that is equal to 10. And the second solution for b is b2. So the second solution for b, b2 equals to 15 minus 5 over 2. 15 minus 5 is 10, and 10 over 2 is 5. So the second solution for b is b2, that is equals to 5. AD is one side of trapezoid ABCD, and the length of side AD is A, and A itself equals to 14 minus 2B. So I write it down. AD equals to A units in its length, and A itself equals to 14 minus 2B. So 14 minus 2b is the length of side AD. So this expression 14 minus 2b is the expression of a length. Therefore it must be a positive number. What is a positive number? A positive number is a number that is greater than 0. So if you found out that 14 minus 2b is greater than 0. Here we let 2b to this inequality, and we get that 14 is greater than 2b. Here we divide this inequality by 2, and finally we get that 14 over 2 is 7, so 7 is greater than 2b over 2 is b. So in total we found out that b must be less than 7 units. Again, b must be less than 7 units from one side, but from the other side, according to the first solution for b, b1 is 10. b1 equals to 10. That is greater than 7 units. But B cannot be greater than 7 units. B must be less than 7 units. So, due to this contradiction, we cancel this solution and we take into account only the second solution for B. The second solution for B is B2 equals to 5. So, B2 equals to 5. We can say that B equals to 5. That is the only solution for B, that B equals to 5. According to our definition, DC equals to B, and B equals to 5, therefore DC equals to 5. B equals to 5 and DC also equals to 5. AB equals to 2 and AD equals to A, and A itself equals to 14 minus 2B. B is 5, so minus 2B is minus 2 times 5, that is minus 10. And 14 minus 10 is 4, so A in total equals to 4 units in its length. Our mission is to find out the area of this trapezoid ABCD. So what is the area of trapezoid ABCD? According to the formula that I presented to you in the beginning of the lecture, the area of this trapezoid ABCD must be equal to the sum of its two parallel bases, that is actually AB plus DC, times the height. The height is AD. Why AD is the height? Because of the fact that AD creates 90 degrees with the base AB, AD creates 90 degrees with the base AB, and AD also creates 90 degrees with the base DC. Therefore, AD is the height of this trapezoid ABCD, divided by 2. So repeat again, if we found out the area of this trapezoid ABCD is equal to the sum of its two parallel bases, that is actually AB plus DC, times the height AD over 2. AB is 2 according to what is given us in the question, plus DC. DC is 5, so it is plus 5, 2 plus 5, times the height AD. AD is 4 units, so AD is 4 divided by 2. So in total, if we found out that the area of this trapezoid ABCD is equal to 2 plus 5 times 4 over 2. 2 plus 5 is 7, and 4 over 2 is 2. So in total, this expression equals to 7 times 2, that is 14. So if we found out that the area of trapezoid ABCD is equal to 14 square units. And that is the answer to the first question. Okay, again, if we found out that the area of this trapezoid ABCD is equal to 14 square units. So we finished with the first question. In the next step, I presented to you the second question. I present to you the second question, and we will solve the second question of this lecture. In the second question, our mission is to find out the area of a different trapezoid. This is totally different trapezoid than the first trapezoid, but with the same name. The name of this trapezoid, it is also ABCD. So our mission is to find out the area of a different trapezoid, ABCD. We know that side AD equals to 2x units in its length, side BC equals to x units in its length, line 7 AM equals to 3 units, line 7 BM equals to 2 units. Those two angles are right angles, and this is angle AMB, this is also a right angle. Our mission is to find out the area of this trapezoid ABCD. So in the first step, we define the size of this angle BMC is alpha. So in the small triangle BCM, this angle equals to alpha, this angle equals to 90 degrees. Therefore, this third missing angle must be equal to 90 degrees minus alpha. Why? Because 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees, it is equal to 180 degrees. That is the sum of the angles in any triangle. DC is one side of trapezoid ABCD, therefore it is absolutely a straight line. So if you focus on the upper side of the straight line DC at point M here, the sum of the angles must be equal to 180 degrees according to rule 3 that states that the sum of the angles on one side of a straight line is equal to 180 degrees. So which angles we have at the upper side of DC at point M? We have this angle that is alpha plus this angle that is 90 degrees plus this missing third angle. In total the sum of those three angles must be equal to 180 degrees according to rule 3. Therefore this third missing angle must be equal to 90 degrees minus alpha. Why? Because 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees, it is equal to 180 degrees. That is the sum of the angles on the upper side of the straight line DC at point M, exactly according to rule 3. Therefore this third missing angle must be equal to 90 degrees minus alpha. So in the right big triangle ADM, this angle equals to 90 degrees minus alpha, this angle equals to 90 degrees, therefore this third missing angle must be equal to alpha. Why? Because alpha plus 90 degrees minus alpha is 90 degrees, and 90 degrees plus 90 degrees, it is equal to 180 degrees. It is the sum of the angles in any triangle. In the next step, we will prove that those two right angles are similar to each other according to angle similarity rule. This is to say, we prove that this is the right triangle ADM that is similar to this right small triangle BCM. So why those two right angles are similar to each other? First of all, those two angles are both equal to alpha, therefore they are equal to each other. In addition, those two angles are both equal to 90 degrees, and therefore they are equal to each other. And finally, those two angles are both equal to 90 degrees minus alpha, therefore they are equal to each other. So in total, we found out that all the figures of the right big triangle ADM are correspondingly equal to all the figures of this right small triangle BCM. And therefore, those two triangles are similar to each other according to angle similarity rule. So I'll write it down. This is the right triangle ADM, the right big triangle ADM. And it's similar, this is the sum of similar to this right small triangle BCM. According to angle similarity rule. And for the fact that those two right triangles are similar to each other, we will derive that the following relationship exists between their sides. We will derive that side AD of this right big triangle ADM over side MC of this right small triangle BCM is equal to side DM of this right big triangle ADM over side BC of this right small triangle BCM. And it is also equal to side AM of this right big triangle ADM over side BM of this right small triangle BCM. So I repeat again, from the fact that those two right triangles are similar to each other, we will derive that the following relationship exists between their sides. That side AD of the right big triangle ADM over side MC of the right small triangle BCM is equal to side DM of the right big triangle ADM over side BC of the right small triangle BCM. It is also equal to side AM of the big right triangle ADM over side BM of the right small triangle BCM. According to what is given in the question, AD equals to 2x, MC is the missing side, so we leave it as it is, and it is equal to dm is also the missing side, so we leave it as it is. Over BC, according to what is given as the question, BC equals to x, and it is equal to AM is 3, also according to what is given as the question, over BM is 2. So in total, we found out that two x over MC equals to dm over x equals to 3/2. So those two expressions are equal to each other, therefore we get the equation 1 from those two expressions that are equal to each other. According to equation 1, we get that 2x over MC equals to 3/2. So write it down. According to equation 1, 2x over MC equals to 3/2. So here we multiply this equation 1 by MC, and we get that 2x equals to 3/2 times MC. So here we multiply this equation 1 by 2, and then we divide it by 3 simultaneously, and we get that MC in total equals to 2 times 2x over 3. So MC in total equals to 2 times 2x is 4x over 3. So MC equals to 4x over 3 in its length. This is side MC that is equal to 4x over 3 in its length. So write it down. MC equals to 4x over 3. Those two expressions are also equal to each other, so we get the equation 2 from those two expressions that are equal to each other. So according to equation 2, we get the dm over x equals to 3/2. So I write it down. According to equation 2, dm over x equals to 3/2. So here we multiply this equation 2 by x, and finally we get that dm equals to 3x over 2 units in its length. So if we found out that the length of this line segment dm is equal, or side dm is equal to 3x over 2 units, 3x over 2 units. In the next step, I'll copy this right small triangle BCM. In the new equation, we'll implement the Pythagoras theorem on this right small triangle BCM. Here by PT is a ratio for Pythagoras theorem. So actually, this is the right small triangle BCM that are coming from the original drawing. This for right triangle BCM according to the Pythagoras theorem. BC squared, that is the square of the hypotenuse, is equal, again, BM squared, that is the square of the hypotenuse, is equal to BC squared plus CM squared. So write it down. BM squared, that is the square of the hypotenuse, is equal to BC squared plus MC squared. According to the Pythagoras theorem, in this one by BCM, the M squared equals to BC squared plus MC squared. BM is 2, therefore BM squared is 2 squared, that is 4. And it is equal to BC squared. BC is x, therefore BC squared is x squared plus MC squared. MC is 4x over 3, therefore MC squared is 4x over 3 squared. So in total, we should find out that four equals to x squared plus 4x over 3 squared. So 4 equals to x squared plus 4x over 3 squared. 4x over 3 squared equals to 4 squared, that is 16, times x squared over 3 squared, that is 9. So in total, we should find out that 4 equals to x squared plus 16x squared over 9. So 4 equals to x squared. So we multiply x squared by 9 and then we divide it by 9 in order to a common factor with this expression, and we get that 4 equals to 9x squared over 9 plus 16x squared over 9. 9x squared plus 16x squared is 25x squared over 9. So in total, I should find out that 4 equals to or 25 over x squared over 9 equals to 4. So here we multiply this equation by 9 and you get that (25x squared) equals to 36. So here we divide this equation by 25 and finally get that x squared equals to 36 over 25. So here we take a root of this equation and finally get that x equals to the square root of 36, that is 6, over square root of 25, that is 5. So in total, x equals to 6/5 units. Okay. Okay. Side BC equals to x, so x equals to 6/5 and AD equals to 2x, that is to say AD equals to 2 times 6/5. Our mission is to find out the area of this trapezoid ABCD. So what is the area of trapezoid ABCD? Actually, the area of any trapezoid, according to the formula that I presented to you at the beginning of the lecture, the area of any trapezoid equals to the sum of its two parallel bases times the height over 2. In this trapezoid ABCD, the two parallel bases are AD and BC. Therefore, it is AD plus BC. That is the sum of the two parallel bases in trapezoid ABCD. So it is AD plus BC times the height over 2. The height of this trapezoid ABCD is DC. Why DC is the height? Because of the fact that DC creates 90 degrees with the base AD, and DC also creates 90 degrees with the base BC. So therefore the height is DC divided by 2. So in total, we should find out that the area of trapezoid ABCD is equal to AD plus BC, that is the sum of its two parallel bases, times the height DC over 2. AD equals to 2x plus BC equals to x times DC in total equals to 3x over 2 plus 4x over 3. So write it down. DC equals to 3x over 2 plus 4x over 3. All divided by 2. So in total, we should find out the area of the trapezoid ABCD is equal to 2x plus x times 3x over 2 plus 4x over 3 divided by 2. 2x plus x is 3x. Divided by 2. Inside the brackets we have 3x over 2 plus 4x over 3. So here we take out 6 as a common factor from those two expressions, and we do it in the following way. We do it by multiplying both the numerator and the denominator of this expression by 3. And we get that 3 times 3x is 9x over 2 times 3, that is 6. And we have also here 4x over 3. So we multiply both the numerator and the denominator of this expression by 2, and we get that 2 times 4x is 8x. And 2 times 3 is 6. So in total, we should find out that the area of trapezoid ABCD equals to 3x over 2, and inside the brackets we have 9x plus 8x over 6. So in total, the area of trapezoid ABCD is equal to 3x over 2, and we have inside the brackets 9x plus 8x, that is 17x, divided by 6. Here we divide both the numerator and the denominator of this expression by 3, and you get that 3x over 3 is x, so in total the numerator will be left with x times 17x, and we have to divide also the denominator by 3, so 6 over 3 is 2, so in total the denominator will be left only with 2 times 2, that is 4. So in the denominator we left with 4, in the numerator we have 17 times x times x. So in total, the area of trapezoid ABCD is equal to 17 over 4 times x times x. We have already found out that x equals to 6/5. Therefore, we substitute x here by 6/5, and we get that the area of trapezoid ABCD is equal to 17 over 4 times x, and x is 6/5, and we have x again, so it is again 6/5. So in total, the area of trapezoid ABCD is equal to 17 over 4 times 6/5 times 6/5. 6 times 6 is 36, and 36 over 4 is 9. So we substitute 6 times 6 over 4 by 9, and we get that in the numerator in total we have 17 times 9, divided by 5 times 5, that is 25. Actually 4, 6 and 6, and substitute 6 and 4 by 9, because 6 times 6 is 36, and 36 over 4 is 9. So substitute the three numbers 6 and 4 by 9. Therefore in total we should find out that the area of trapezoid ABCD is equal to 17 times 9, that is 153, over 25. In terms of numbers, it is equal to 6.12 square units. And that is the answer to the second question. Because again, if you found out that the area of this trapezoid ABCD is equal to either 153 over 12 square units, or in terms of numbers, the area of this trapezoid ABCD is equal to 6.12 square units. So we finish with the second question. The next step, I'll summarize the lecture. I'll start with the first question, of course. But before that, what is a trapezoid? A trapezoid is a quadrilateral with one pair of parallel sides. This is quadrilateral ABCD. It is a quadrilateral because it has 4 sides, and because of the fact that side AB is parallel to the opposite side DC, this quadrilateral ABCD is defined as a trapezoid. If we define the length of side AB as B and the length of side DC as A, then the area of this trapezoid will be equal to the sum. Actually, AB and DC are defined, the two parallel sides, that is to say AB and DC, are defined as the bases of this trapezoid. So the area of this trapezoid ABCD will be equal to the sum of its two parallel bases, that is actually A plus B, times the height edge over 2. The height edge must create 90 degrees with the two parallel bases. Okay, so a trapezoid is a quadrilateral with one pair of parallel sides, and the area of the trapezoid is equal to the sum of its two parallel bases times the height edge over 2. So in the first question, we have to find out the area of trapezoid ABCD. Then again, in the first question, we have to find out the area of this trapezoid ABCD. It is given as a question that the perimeter of this trapezoid ABCD is equal to 16 units. So, what is the perimeter of a trapezoid? The perimeter of a trapezoid is the sum of the lengths of all the sides of a trapezoid. Again, the perimeter of a trapezoid is the sum of the lengths of all the sides of the trapezoid. This trapezoid ABCD, it is AB plus AD plus DC plus CB. And we know that it is equal to 16. The perimeter is 16. We know that also that AB equals to 2 units in its length. Those two angles are right angles. And side BC equals to side CD. In the next step, we define the length of side AD as A. That is to say, AD equals to A units in its length, DC equals to B units in its length, according to our definition. And because of the fact that BC equals to CD, according to what is given as the question, and DC is B, therefore BC must be also equal to B. So the perimeter of this trapezoid is equal to 16. That is to say, AB plus AD plus DC plus CB equals to 16. AB is 2 according to what is given us in the question. AD is A according to our definition. DC is B also according to our definition. And CB is B according to our definition. It is equal to 16. So in total, we have found that 2 plus a plus b equals to 16. Here we subtract 2 from this equation and finally found out that a plus b that is a plus 2b equals to 16 minus 2, that is 14. A plus 2b equals to 14. So here we subtract the 2b from this equation and finally found out that a equals to 14 minus 2b. Side AD equals to a units in itself, and a itself equals to 14 minus 2b units. In the next step, we did a construction, that is to say, from the vertex B, we draw perpendicular on DC. So this angle equals to 90 degrees, and this angle also equals to 90 degrees, according to our construction. When doing this construction, we can do it for the angle ABMD. Inside this quadrangle ABMD, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees, so 270 degrees plus the side of this missing angle, in total the sum of those 4 angles must be equal to 360 degrees, according to the rule that said that the sum of the angles in any quadrangle is equal to 360 degrees. And therefore this 4th missing angle must be equal to 90 degrees in its size. So inside the quadrangle ABMD we have 4 right angles, and according to rule 5, any quadrangle that has 4 right angles must be this rectangle in front of square. So we know to this quadrangle ABMD is a rectangle because it has 4 right angles. But we also know that the opposite sides of a rectangle are equal to each other. So in rectangle ABMD, side AB must be equal to the opposite side DM. But AB is 2, according to what is given in the question. So the opposite side DM must be also equal to 2 units in its length. Likewise, according to the same rule, in the same rectangle ABMD, side AD must be equal to the opposite side BM. But AD is 14 minus 2B, therefore the opposite side BM must be also equal to 14 minus 2B units in its length. What is the length of this missing side MC? MC equals to DC minus DM. Again, MC equals to DC minus DM. So MC equals to DC. DC is B according to our definition, minus DM. Just like the found out, the DM equals to 2. So in total, MC equals to B minus 2. In the next step, I copied this right triangle BMC in a new page and implemented the Pythagoras theorem in this right triangle BMC. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the slopes of the perpendiculars. So actually, this is the right triangle BMC that I copied from the original drawing. According to the Pythagoras theorem, in this right triangle BMC, BC squared, that is the square of the hypotenuse, equals to BM squared plus MC squared. BC is B, therefore BC squared is B squared, and it is equal to BM squared. BM is 14 minus 2B, therefore BM squared is 14 minus 2B squared plus MC squared. MC is B minus 2, therefore MC squared is B minus 2 squared. So in total, we found out that B squared equals to 14 minus 2B squared plus B minus 2 squared. We open the brackets on this side of this equation and finally found out that B squared equals to 14 minus 2B squared. 14 minus 2B squared equals to 14 squared, that is 196, plus 2B squared. 2B squared is 4B squared, minus 2 times 14 times 2B. Minus 2 times 14 is minus 28, and minus 28 times 2B is minus 56B. And we have also plus B minus 2 squared. B minus 2 squared equals to B squared, plus 2 squared, that is 4, minus 2 times B times 2, that is minus 4B. So here we have B squared on both sides of this equation, so B squared will get cancelled. After cancelled B squared, in this side of the equation we left with nothing, that is to say 0, while on the other side of the equation we left with 196 plus 4, that is 200, and we have also minus 56B, minus 4B, that is minus 60B, plus 4B squared. So in total, if we found out that 0 equals to 200, minus 60B plus 4B squared. Here we divided this equation by 4 and found out actually that 4B squared over 4 is B squared, minus 60B over 4 is minus 15B, and 200 over 4 is 50. So in total we found out that B squared minus 15B plus 50 equals to 0. So this is a quadratic equation, and the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. A, B, and C in this general formula are the coefficients of this quadratic equation, and x is the variable that we are looking for. and we find out the value of x according to the following formula. X equals to minus b plus minus square root of b squared minus 4 times a times c over 2a. In our specific quadratic equation, that is to say b squared minus 15b plus 50 equals to 0, the variable that we are looking for is small b. So x equals to small b. The coefficient a equals to 1, the coefficient b equals to minus 15, and the coefficient c equals to 50. So the only thing that is left to do is to put this data of our specific quadratic equation inside this general formula for x, and in this way we find out the value of the values of small b, because x equals to small b is the variable that we are looking for in our specific quadratic equation. So we did it, and we found out that because of the fact that x equals to b, we substitute x by small b, and it is equal to minus b. B is minus 15, therefore minus b is minus 15, that is plus 15, plus minus square root of b squared. B is minus 15, therefore b squared is minus 15 squared, that is 225, minus 4 times a times c. So it is minus 4 times a. A is 1, so minus 4 times 1 is minus 4 times c. C is 50, so minus 4 times 50 is minus 200. So in total inside the root we have 225 minus 200 over 2a. A is 1, so 2a is 2 times 1, that is 2. So in total if we found out that b equals to 15 plus minus, inside the root we have 225 minus 200, that is 25. So inside the root we left only with 25 over 2. So in total if we found out that b equals to 15 plus minus, and the square root of 25 is 5, divided by 2. So here we have two solutions that are possible for b. We define the first solution for b is b1, and the second solution for b is b2. So the first solution for b is b1, and b1 is equal to 15 plus 5 over 2. 15 plus 5 is 20, and 20 over 2 is 10. So the first solution for b is b1, and b1 equals to 10. The second solution for b is b2, and b2 equals to 15 minus 5 over 2. 15 minus 5 is 10, and 10 over 2 is 5. So the second solution for b is b2, that equals to 5. We know that AD is one side of trapezoid ABCD, and the length of side AD is A, and A itself equals to 14 minus 2B. Okay, again, AD equals to A, and A is 14 minus 2B. 14 minus 2B is an expression of a length, and a length must be a positive number. That is to say, 14 minus 2B must be a positive number. What is a positive number? A positive number is a number that's greater than 0. Therefore, 14 minus 2b must be greater than 0. Here we added to this inequality 2b, and found out actually that 14 is greater than 2b. Here we divided this inequality by 2, and finally found out that 14 over 2 is 7, and it is greater than 2b over 2 is b. So in total, we actually found out that b must be less than 7 units. Again, b must be less than 7 units. But according to the first solution for b, b1 equals to 10, that is greater than 7. B cannot be greater than 7, b must be less than 7. So due to this contradiction, we cancel the first solution for b, and we took into account only the second solution for b, that is b2, that is equals to 5. So in total, we found out that the only solution for b is that b equals to 5 units in its length. So here we have DC equals to B according to our definition, and B equals to 5. So DC equals to 5, AB equals to 2, AD equals to 4. Why AD equals to 4? Because AD equals to A, and A equals to 14 minus 2B. B is 5, so minus 2B is minus 2 times 5, that is minus 10. And 14 minus 10 is 4. So in total, AD equals to 4. AB equals to 2, and DC equals to 5. Our mission is to find out the area of this trapezoid ABCD. According to the formula that I presented to you in the beginning of the lecture, the area of any trapezoid must be equal to the sum of its two parallel bases. In this case, it is AB plus DC times the height, that is AD over 2. Then again, the area of this trapezoid ABCD equals to the sum of its two parallel bases, That is actually AB plus DC times the height, that is AD over 2. AB is 2 according to what is given as the question. DC is 5 because DC equals to B and B is 5. So AB is 2, DC is 5, and AD is 4. AD is 4, all divided by 2. So in total, we found out that the area of trapezoid ABCD is equal to 2 plus 5 times 4 over 2. 2 plus 5 is 7, and 4 over 2 is 2. So in total, this expression equals to 7 times 2, that is 14. So we found out that the area of this trapezoid ABCD is equal to 14 square units. We finished with the first question. In the next step, I presented to you the second question, and this was the second question of this lecture. In the second question, our mission is to find out the area of another trapezoid with the same name. We have to find out the area of this trapezoid with the same name that is also trapezoid ABCD, but it is different trapezoid. It is not the trapezoid of the first question. So, in this trapezoid ABCD, side AD equals to 2x units in its length, side BC equals to x units in its length, AM equals to 3 units, and BM equals to 2 units. Those two angles are right angles, and this is again A and B, that is also a right angle. Our mission is to find out the area of this trapezoid ABCD. So first of all, we define the size of this angle BMC as alpha. So in the right small triangle BMC, this angle equals to alpha, this angle equals to 90 degrees, and therefore this third missing angle must be equal to 90 degrees minus alpha. Why? Because 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees is equal to 180 degrees. That is the sum of the angles in any triangle. DC is one side of trapezoid ABCD, therefore it is absolutely a straight line. So if you focus on the upper side of DC at point M, if the sum of the angles must be equal to 180 degrees, according to rule 3, that says that the sum of the angles on one side of a straight line is equal to 180 degrees. So which angles we have at the upper side of DC at point M? We have this angle that is alpha, this angle is right angle, according to what is given as the question, plus this third missing angle. In total, the sum of those two angles must be equal to 180 degrees, according to rule 3. Therefore, this third missing angle must be equal to 90 degrees minus alpha. Why? Because 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees, it is equal to 180 degrees. That is the sum of the angles on the upper side of DC at point M, according to rule 3. So this third missing angle must be equal to 90 degrees minus alpha. In the right bit, triangle ADM, this angle equals to 90 degrees minus alpha, this angle equals to 90 degrees, therefore this third missing angle must be equal to alpha. Why? Because alpha plus 90 degrees minus alpha is 90 degrees, and 90 degrees plus 90 degrees, it is equal to 180 degrees. That is the sum of the angles in a triangle. The next step, we prove that those two right angles are similar to each other according to angle similarity rule. That is to say that this is the right triangle ADM, the right big triangle ADM, that is similar to this small right triangle BCM. So why those two right triangles are similar to each other? First of all, those two angles are both equal to alpha, therefore they are equal to each other. In addition, those two angles are both equal to 90 degrees, therefore they are equal to each other. And finally, those two angles are both equal to 90 degrees minus alpha, therefore they are equal to each other. So in total, we found out that all the angles of this right big triangle ADM are correspondingly equal to all the angles of this right small triangle BCM. And therefore, those two right angles are similar to each other according to angle similarity rule. And from the fact that those two right angles are similar to each other, we derive that the following relationship exists between their sides. The side AD of this big right triangle ADM over side MC of this small right triangle BCM is equal to side DM of this right big triangle ADM over side BC of this small right triangle BCM, and it is also equal to side AM of this big right triangle ADM over side BM of this right small triangle BCM. So repeat again, from the fact that those two right triangles are similar to each other, we derive that the following relationship exists between their sides. That AD over MC equals to DM over BC equals to AM over BM. AD is 2x, BC is x, AD is 2x, MC is the missing side, so we leave it as it is. DM is the missing side, so we leave it as it is, over BC. BC is x, and it is equals to AM, that is 3, over BM, that is 2. So in total, if you found out that 2x over MC equals to 2x over mc equals to dm over x equals to 3/2. Those two expressions are equal to each other, therefore we created equation 1 from those two expressions that are equal to each other. So according to equation 1, we get that 2x over mc equals to 3/2. 2x over mc equals to 3/2. Here we multiply this equation by mc and find that 2x equals to 3/2 times mc. Here we multiply this equation by 2 and then we divide it by 3 simultaneously and finally found out that mc equals to 2 times 2x over 3. 2 times 2x is 4x, and total this expression equals to 4x over 3. So mc equals to 4x over 3 units in its length. This is at mc, this is equal to 4x over 3 units in its length. Those two expressions are also equal to each other, therefore we get the equation 2 from those two expressions that are equal to each other. So according to equation 2, dm over x equals to 3/2. dm over x equals to 3/2. Here we multiply this equation by x and found out actually that dm equals to 3x over 2. dm equals to 3x over 2 units in its length. In the next step I copied this right small triangle BCM in a new page and implemented the Pythagoras theorem in this right triangle BCM. Actually, this is the right small triangle BCM that I copied from the original drawing. In this right small triangle BCM, according to the Pythagoras theorem, bm squared, that is the square of the hypotenuse, equals to bc squared plus mc squared. And again, according to the Pythagoras theorem, in this right triangle BCM, bm squared, that is the square of the hypotenuse, equals to bc squared plus mc squared. bm is 2, therefore bm squared is 2 squared, that is 4, plus bc squared. bc is x, therefore bc squared is x squared, plus mc squared. mc is 4x over 3, therefore mc squared is 4x over 3 squared. So in total we can find out that 4 equals to x squared plus 4x over 3 squared. So 4 equals to x squared plus 4x over 3 squared. 4x over 3 squared equals to 4 squared, that is 16, times x squared over 3 squared, that is 9. So in total 4x over 3 squared equals to 16x squared over 9. So we found out that 4 equals to x squared plus 16x squared over 9. Here we multiply the x squared by 9 and then we divide it by 9 in order to overcome factor with this expression. And finally found out that 4 equals to 9x squared plus 16x squared divided by 9. 9x squared plus 16x squared is 25x squared divided by 9. So in total we found out that 25x squared over 9 equals to 4. Again, 25x squared over 9 equals to 4. Here we multiply this equation by 9 and finally found out that 25x squared equals to 4. 9 times 4, that is 36. Again, 25x squared equals to 36. Here we divided this equation by 25 and found out that x squared equals to 36 over 25. Here we took out a root from this equation. We took out of this equation, and finally found out that x equals to the square root of 36, that is 6, over square root of 25, that is 5. So in total x equals to 6/5. Okay. Our mission is to find out the area of this trapezoid ABCD. According to the formula that I presented to you at the beginning of the lecture, the area of this trapezoid ABCD must be equal to the sum of its two parallel bases, that is actually AD plus BC, times the height, that is DC over 2. So the area of this trapezoid ABCD is equal to the sum of its two parallel bases, that is actually AD plus BC, times the height DC over 2. AD is 2x plus BC, BC is x, times DC. Again, AD is 2x, BC is x, times DC. DC in total equals to 3x over 2 plus 4x over 3. Okay, again, DC in total equals to 3x over 2 plus 4x over 3, all divided by 2. 2x plus x is 3x, so we have 3x over 2. Inside the brackets we have 3x over 2 plus 4x over 3. Here we took out 6 as a common factor from those two expressions, and we did it by just multiplied both the numerator and the denominator of this expression by 3. 3 times 3x is 9x, and 2 times 3 is 6. Likewise, we multiply both the numerator and the denominator of this expression by 2. 2 times 4x is 8x, and 2 over 3 is 6. So you can see that by doing these operations, we actually created a common factor of 6, that is the common factor of those two expressions. So in total, we have found out that the area of trapezoid ABCD equals to 3x over 2. Inside the brackets we have 9x plus 8x over 6. So it is 3x over 2, and 9x plus 8x is 17x over 6. So in total, the area of trapezoid ABCD equals to 3x over 2 times 17x over 6. Here we divided both the numerator and the denominator of this expression by 3. 3x over 3 is x, so in total in the numerator we have x times 17x, and 6 over 3 is 2, so in total in the denominator we have 2 times 2. So the area of trapezoid ABCD is equal to 17 times x over 2 times 2, that is 4. So it is 17 over 4 times x. But we have only found out that x equals to 6/5. So we can substitute x by 6/5. We did it, and we found out that the area of trapezoid ABCD equals to 17 over 4 times x. X is 6/5, and we have x again, so it is 6/5 again. So in total, the area of trapezoid ABCD equals to 17 over 4 times 6/5 times 6/5. 6 times 6 is 36, and 36 over 4 is 9. So we substitute 6 times 6 over 4 by 9. So in total, in the numerator we have 17 times 9. In the denominator we have 5 times 5, that is 25. So in total, the area of trapezoid ABCD equals to 17 times 9, that is 153 over 25. So the area of this trapezoid ABCD is equal to either 153 over 25 square units. So in terms of numbers, the area of this trapezoid ABCD is equal to 6.12 square units. Okay, thank you very much.